Hello everyone, good evening to all of you. Welcome to Gate Academy or An Academy. So now I will discuss in front of you a next important problem for Gate 2023 in Transportation Engineering, and this is our last session. The question is, the plate load test conducted with a 75 centimeter plate. The diameter of plate is 75 centimeter is given in the problem. On a soil subgrade yield a deflection of 2.5 mm. So 2.5 mm deflection is also given in the question under a stress of 800 Newton per centimeter square. So the value of stress or pressure, that means a small p, is directly given. The modulus of elasticity of subgrade is in kilonewton per meter square. So the value, so the question is how to calculate the modulus of subgrade reaction. So if I am interested to calculate modulus of subgrade reaction, we already know that, my dear friends. If I will talk about so plate load test, if I will talk about plate load test, so how to calculate deflection? So deflection is become equal to 1.18 small p multiplied by a upon delta multiplied by f2. Am I right? So if we already know that if f2 is not given in the problem, if f2 is not given in the problem, then you directly consider f2 is become equal to 1. If you considering f2 is become equal to 1, what do you mean about delta? So delta is 2.5 mm is given, converting into a centimeter. So 2.5 dividing by 10, this is converting into centimeter, is become equal to 1.18 multiplied by small p. What is the value of a small p, my dear friend? So the value of a small p is 800 Newton per centimeter square. And what do you mean about, sorry, the value is 1.18 pa upon delta. I really sorry, the value is 1.18 small p into a upon es multiplied by f2. This is the formula. So we already know that f2 is not given, then you consider f2 is become equal to 1. So now you put the value 1.18 multiplied by small p. So the value of small p is become equal to 800 multiplied by small a, that means radius. So 75 centimeter is the diameter, dividing by 2. This is the value of radius. And if the question is what is the value of es, what is the value of es, this is the question. So now how to calculate the value of es, my dear friend? How to calculate the value of es? If I am interested to calculate the value of es, so es is become equal to, what is the value of Young's modulus elasticity of subgrade? So Young's modulus elasticity of subgrade, we will come 141.6 kilonewton per centimeter square. This is the formula, my dear friend. This is the answer. This is our correct answer. Okay? So it is the value of modulus of subgrade reaction. So option A is correct. Then this way we can solve this type of problem. Now see here, I will discuss in front of you a next problem, and the next problem is related to GATE 1997 IIT Madras, and it is related to expansion joint. We already know that the width of expansion joint is 2.5 centimeter. So 2.5 centimeter width of expansion joint is given. That means delta is given in the problem. We already know that the value of delta is become equal to how much? So the value of delta is become equal to 2.5 centimeter. In a cement concrete pavement, the spacing between expansion joint maximum rise in temperature is 25 degrees Celsius. So that means change in temperature is directly given in the question, and the change in temperature is become equal to 25 degrees Celsius is directly given. Expansion joint, and assuming coefficient of thermal expansion of concrete. So assuming coefficient of thermal expansion of concrete is 10 into 10 raised to power minus 6, and the value is in per degree Celsius. It is already given. My dear friend, good evening to all of you. Good evening, Sanku. The main question is what is the value of, what is the spacing between expansion joint? We already know that gap of expansion joint provided in such a way that after expansion delta by 2 gap should always be maintained. So delta by 2 is become equal to L multiplied by T, and T is the change in temperature. My dear friend, if I will talk about delta, so delta is 2.5 dividing by 2 is equal to L, that means spacing between two expansion joint, multiplied by alpha. So the value of alpha is 10 into 10 raised to power minus 6 multiplied by change in temperature, that means T. So change in temperature is become equal to 25 degrees Celsius. You can calculate the value of capital L. Now please calculate what do you mean about capital L. Please calculate what do you mean about capital L. So 2.5 dividing by 2 dividing by 10 raised to power minus 6 multiply by 10 multiply by 25. So the value is become equal to, I think the value is become equal to 5000 I think the value is become equal to 5000 centimeter. If 5000 centimeter, then it is converting into a meter, is become equal to 50 meter. Am I right? So capital L is become equal to how much meter? Capital L is become equal to 50 meter. That means option B is correct. Clear? So it is one of the very easiest problem. Now I will discuss a next important problem in front of you, and the problem is the modulus of subgrade reaction is obtained from the plate bearing test. Am I right? So the question is the modulus of subgrade reaction is obtained from the plate bearing test in the following load deflection curve. The pressure corresponding to the following settlement value should be used. So my dear friend, we already know that if I draw a plot, that means in between deflection, in between load upon deflection, in between load versus deflection, load is in kilogram and deflection is in centimeter. Am I right? So load versus deflection curve is looking like this. This is our load versus deflection curve. The load corresponding to which deflection is obtained? So the load corresponding to 0.125 centimeter is considered as it is calculate the value of load or pressure. Am I right? So the value is become equal to C. C option is correct. It is very easy and it is conceptual problem, my dear friends. Now see, what is the next question? The next question is what this question I think already discussed in front of you. This type of question I already discussed in front of you. I will I discuss here some extra new problems. I will discuss some extra new problems because all the questions are already discussed. These type of questions are already discussed. Now the main question is question like this. The question is this, or the question is this. Firstly, the question is this. And the question is the tie bar of 12 mm diameter. Am I right? Diameter of tie bar is already given in the question. The diameter of tie bar is 12 mm. 12 mm diameter of tie bar is given. Are to be provided in a cement concrete slab. Am I right? Are to be provided in a cement concrete slab. The working tensile stresses of tie bar is 2000 megapascal. So working tensile stress is already given. The average bond strength between tie bars and concrete is 2 megapascal. Am I right? And the joint gap between the slab is 10 centimeter. Okay, joint gap is already given. Joint gap between the slab is 10 centimeter. Ignoring the loss of bond and the tolerance factor, the design length of tie bar. What is the design length of tie bar? We already know that. How to calculate design length of tie bar? Firstly write given data here. Firstly wrote given data here. So now see here. If I am interested to calculate given data, just a wait please. If I am interested to calculate given data, so given data is diameter of bar is also given. Diameter of bar, that means phi, is become equal to 12 mm. Similarly, sigma st is already given. Tensile strength of steel is already given. Sigma st, that means 230 megapascal. Bond stress between concrete and steel, that means tau bd is also given in the question, and the value of tau bd is become equal to how much? The value of tau bd is 2 megapascal is given. The joint gap, that means delta is already given, and the delta is become equal to how much mm? This is 10 mm is given to you. The main question is calculate length of tie bar. So we already know that if I am interested to calculate length of tie bar, final length of tie bar is equal to final length of tie bar. So final length of tie bar LT is equal to development length plus gap is delta. So how to calculate development length in this case? So development length is become equal to phi into sigma st. In highway engineering it is 2 tau bd, but if I will talk about RCC, this is 4 tau bd. Am I right? So the development length is become equal to phi into sigma st dividing by 2 tau bd. So my dear friend, phi is already given in the question. Phi is 12 mm multiply by sigma st. So sigma st is become equal to 230 megapascal dividing by 2 multiply by tau bd is already given, and tau bd is also 2. So my dear friend, if you solve this, so 6 times this will be cancel out. So 2 3 times this will be cancel out. So it's become equal to 3 3s are 9, 3 2s are 6, that means 690 mm it is development length. So 690 mm is the development length plus what is the value of delta? So the value of delta sorry, the value of delta is directly given. The delta is become equal to 10 mm. So delta is become equal to 10 mm, that means plus delta is there. So what is the value of length of tie bar? So length of tie bar is become equal to how much? This is become equal to 700 mm. So it is one of the easiest problem. I think GATE 2021 or GATE 2020 problem is there. Am I right? Now, so this problem is very easiest. Please remember this point. If you are interested to calculate development length, then you never be used directly phi into sigma st dividing by 4 tau bd. In case of highway engineering, formula will come out 2 tau bd. Am I right? In live class, I already discussed in detail with derivational proof. Clear to all? So I will discuss in front of you a next important problem, and next important problem, this problem is already asked in GATE 2022 or 2021 also, 2021 or 2022. Now see, what is the problem? In a CBR test, on a soil sample, the following data were observed. In the providing ring of test, 100 division are represented 180 kilogram. Okay, so there will be a one ring, see here, there will be a one ring, and this ring represent this ring having 100 divisions, and 100 division is represent 180 kilogram load. 100 division represent 180 kilogram load. Am I right? 100 division represent 180 kilogram load. Now see here, now one division is represent how much load? 180 dividing by 100, that means 1.8 kilogram load. So 1 division is represent 1.8 kilogram of loading. Am I right? One division is represent 1.8 kilogram of loading. 180 dividing by 100, that means 1.8 kilogram of loading. See here please. If I will talk about 10 0.5 mm penetration of plunger is in mm is given in the problem, and load reading is already given. For 0.5 mm penetration, 10 load reading, yani 10 reading, that means one division is equal to 1.8 kg, then 10 reading, that means 10 division, that means 1.8 multiplied by 10 is 18 kg. Am I right? The question is, what is the value of CBR percent? So we already know that if I am interested to calculate CBR percent, then CBR percent is the maximum of CBR percent at 2.5 mm penetration or CBR percent at 5 mm penetration. So now see here, 2.5 mm penetration, that means 34 number of division. Am I right? Or 34 number of division is there. So my dear friend, we already written like this: at 2.5 mm penetration, load is equal to how many number of division? 34 division is there, and multiply by 1.8, because one division is equal to 1.8 kg. Then 34 multiplied by 1.8 is equal to 61.2 kilogram. 34 multiplied by 1.8 is equal to 61.2 kilogram. Similarly, if I will talk about at 5 mm penetration, if 5 mm penetration load, if I will considering 5 mm penetration load, so 5 mm penetration 92 load reading is there. If 92 load reading is there, that means 92 multiplied by 1.8. So 92 multiplied by 1.8 is equal to 92 multiplied by 1.8 is equal to 165.6 kilogram. 165.6 kilogram, it is the value. This is the value. We already know that if I am interested to calculate CBR percent, so CBR percent is become equal to, what do you mean about CBR percent? To CBR percent, if I am interested to calculate CBR percent, then we already know that CBR percent is equal to maximum of load corresponding to 2.5 mm penetration dividing by standard load, that means 1370 kilogram multiplied by 100, and load corresponding to 5 mm penetration dividing by 2055 multiplied by 100. My dear friend, if I will talk about P 2.5, that means 61.2 kilogram dividing by 1370 multiplied by 100, so the value will come out 61.2 dividing by 1370 multiplied by 100, so the value will come out 4.46%. So the value will come out 4.46%. Similarly, if I am interested to calculate CBR percent at 5 mm penetration, so CBR percent at 5 mm penetration, what is the value of P5? So the value of P5 is 165.6 kilogram dividing by standard load is 2055 kilogram multiplied by 100. So the value will come out is equal to 165.6 dividing by 2055 multiplied by 100. So the value will come out is equal to I think the value is become equal to 8 point something percent, 8.05%. Am I right? So in the whichever is maximum, that means penetration CBR percent 5 is maximum. So option is this. I think something is wrong. 165.6 dividing by 2055. Yes, all the things are correct or not? Yes, all the things are correct, I think, है ना? So 8.5005% is the correct answer. This is the correct value of CBR percent. Clear to all of you? So this is the correct value of CBR percent. I will discuss in front of you a next important problem, my dear friend. If I will talk about in front of you a next important problem, then now see here. What is the so the question is like this. This is the question. Now see, the problem is very important. Find the vehicle damage factor. Find vehicle damage factor for a pavement drawing design traffic 100 million standard axle. Okay. As per Indian Road Congress 37, information regarding to highway design life is 20 years is given in the question. Commercial vehicle counted after contribution completed, after it's not contribution, it is construction. After construction is completed is 1500 vehicles per day, and annual traffic growth rate 10% per annum is directly given. Am I right? The main question is please calculate the value of vehicle damage factor. We already know that this problem is related to modified CBR method. So if what is the formula? So formula is number of cumulative standard axle in terms of millions. So NS is equal to 365A under bracket 1 plus R upon 100 raised to power n minus 1 dividing by R by 100 multiply by lane distribution factor multiply by vehicle damage factor, multiply by lane distribution factor and multiply by vehicle damage factor. My dear friend, now you put the value here. If you put the value, so 365 multiplied by A, so the value of A is become equal to A is already given, this is 1500 vehicle per day. NS is already given 100 million standard axle. So 100 million, that means 100 multiplied by 10 raised to power 6 standard axle. Am I right? Because we already know that 1 million is equal to 10 lakh. 1 million is equal to 10 lakh, that means 1 million is equal to 10 raised to power 6. Correct or not? 1 million is equal to 10 raised to power 6. Now see here please, now see here, see here please. So my dear friends, you put the value, if you putting the value here, if you put the value here, 1 plus R by 100, so 1 plus traffic growth rate is 10%, multiply by n, that means design life, and design life is 20 years, so whole is whole to the power 20 minus 1, dividing by R by 100, that means 10 dividing by 100, multiply by lane distribution factor. So lane distribution factor is not given, then you consider 1. Vehicle damage factor, we can calculate the value of vehicle damage factor here. Then please calculate what is the value of vehicle damage factor. Please solve this equation, get the answer. What is the value of vehicle damage factor? Anybody else? Please calculate the value. What is the value of vehicle damage factor here? What is the value of vehicle damage factor? So we already know that, this equation is also written like, 100 into 10 raised to power 6, 100 into 10 raised to power 6 is become equal to 10 by 100 plus 1 whole raised to power 20 minus 1 dividing by 10 dividing by 100 multiply by 365 multiply by 1500. So 100 E6 dividing by this answer. So vehicle damage factor will come out is equal to, 3.19. It is the value of vehicle damage factor. Am I right? This is the value of vehicle damage factor. Vehicle damage factor will come out 3.19. Clear? So it is one of the very easiest problem. It is also one of the very easiest problem. Next question which I discuss, the compute the radius of relative stiffness. We already know that if I am interested to calculate radius of relative stiffness, now what is the formula? Radius of relative stiffness always be come out is in centimeter. Am I right? So radius of relative stiffness is represented by a small l. Radius of relative stiffness is represented by a small l, and small l is in centimeter. We already know that. My dear friend, please see here properly. If I am interested to calculate small l is in centimeter, so the value is become equal to EH cube dividing by 12k1 minus mu square whole raised to power 1 by 4. This is the value. Whole raised to power 1 by 4. This is the value. So my dear friend is equal to, this is equal to EHQ. So what do you mean about E? The value of E is become equal to 2.1 into 10 raised to power 5 kilogram per centimeter square dividing by 12k. Now what is the value of K? So the value of K is load sustained by rigid plate. K is the modulus of subgrade reaction, I think, K is modulus of subgrade reaction. Okay. So what is the radius of relative stiffness of 20 mm thick plate? So EHQ, HQ, that means 20 centimeter is already given. So this is 20 ka cube dividing by 12k 1 minus mu square. So K I think is not given. Actual load sustained by rigid plate is 2000 kg. If I am interested to calculate the value of K, then we already know that the modulus of subgrade reaction K is equal to P dividing by 0.125 centimeter. Am I right? P dividing by 0.125 centimeter. This is the value of small p dividing by 0.125 centimeter. But small p is not given. Actual load is given. Okay, small p is not given. Actual load is given. So we already know that we can calculate the value of small p. How to calculate the value of small p? So small p is equal to, always we use 75 diameter plate. So 75 diameter plate, that means load is become equal to how much? Load is become equal to 2000 kilogram. It is the value of load. Dividing by, what is the area? Area is pi by 4 multiplied by d square, that means 75 square. Now you can calculate the value of pressure or stress. So what is the value of pressure, my dear friend? So pressure is become equal to 2000 multiplied by 4 dividing by pi multiplied by pi multiplied by 75 square. So the value is become equal to 0.5 0.452 kilogram per centimeter cube. Am I right? Sorry, per centimeter square. We already know that if I am interested to calculate modulus of subgrade reaction, now you put the value P here. So 0.452 dividing by 0.125. So the value of K is become equal to, so the value of K is become equal to dividing by 0.125. So K is become equal to 3.62 kilogram per centimeter cube. It is the value of small k. Modulus of subgrade reaction, and modulus of subgrade reaction K is equal to 3.62 kilogram per centimeter cube. So this is 3.62 multiplied by 1 minus mu square. Poisson's ratio is already given 0.15 square whole raised to power 1 by 4. Now you can calculate the value of radius of relative stiffness is in centimeter. Anybody interested to calculate the value of relative stiffness? What will be the value? Anybody else? What will be the correct value? So 2.1 into 10 raised to power 5 multiplied by 20 cube dividing by 12 multiplied by 3.62 multiplied by 1 minus 0.15 square whole raised to power 1 by 4. So the value is become equal to 79.32 centimeter. Am I right? 79.3 centimeter. It is the value of radius of relative stiffness. Clear? So this is our correct answer. This is our correct answer. Clear to all of you? So question is very easy but little bit conceptual. Now the next problem, and this problem is very interesting. The width of expansion joint is 2.5 centimeter. So 2.5 centimeter width of expansion joint is given for CC pavement. If lagging temperature is 10 degrees Celsius and maximum, this is 10, only 10 degrees Celsius. The lagging temperature is 10 degrees Celsius and the maximum temperature in summer season is 54 degrees Celsius. Clear? So calculate spacing between expansion joint. Am I right? I repeat again and again, the gap of expansion joint provided, that means delta is provided in such a way that after expansion delta by 2 gap should always be maintained. Am I right? So my dear friend, we already know that if I am interested to calculate spacing between expansion joint, so delta by 2 gap should always be maintained. Delta by 2 is equal to L alpha multiplied by T, where T is the change in temperature. Am I right? T is the change in temperature. Alpha is not given, so you always be consider alpha of concrete, that means coefficient of thermal expansion of concrete is equal to 10 into 10 raised to power minus 6 per degree Celsius. Clear? So the value of alpha, the coefficient of thermal expansion of concrete, is become equal to 10 into 10 raised to power minus 6 per degree Celsius. This is the value of alpha. Clear? Now you put the value. What do you mean about T? So T is not a temperature. Please remember this point. T is not a temperature. T is the change in temperature. Clear? If I will talk about T, so T is not a temperature. T is the change in temperature. T is a change in temperature. So now see here, if I will talk about T, so T is the change in temperature. Now what is the change in temperature, my dear friends? So change in temperature is become equal to, what is the highest temperature? Highest temperature is 54 degrees Celsius. What is the lowest temperature? Lowest temperature is 10 degrees Celsius. Then what is the change? 54 minus 10 degrees Celsius is become equal to 44 degrees Celsius is the temperature difference. Am I right? This is a difference in temperature. So now you put the value. What do you mean about delta? Delta is already given in the question, and the value of delta is 2.5 centimeter dividing by 2 multiply by L multiply by 10 into 10 raised to power minus 6. It is the value of alpha, and the change in temperature is become equal to 54 degrees Celsius minus 10 degrees Celsius. So you can calculate the value of L, that means spacing between expansion joint. Now what is the value of spacing between expansion joint here? Please calculate it. So if I am interested to calculate 2.5 dividing by 2 dividing by 44 dividing by 10 raised to power minus 6, so the value is become equal to 2840.90 centimeter, and dividing by 100, if I am dividing by 100, then it become equal to 28.4 meter. It is the value of spacing between expansion joint. Clear? This is the value of spacing between expansion joint. Very easy question. Very easy, I think. Am I right? Now, next question is also very interesting and very easiest problem, and this problem related to building material, and another problem related to highway, another problem related to, after that next problem is related to railway or airway engineering. So remaining problems I discuss in front of you in next class. It is sufficient for today class. Thank you. If you are interested to attend a revision series in highway engineering, then please come on Gate Academy's Civil Mechanical channel at 9 p.m. Today is, I think, 4th session is there. Am I right? Traffic engineering will be covered for today lecture. So please, if you are interested, then please come and join. Thank you so much for this class. Thanks everyone. Good night. Jai Hind.